Again, I want to remind you, if you see these magenta links, there's a link to somebody else doing the problem. And again, I do recommend you look at other people do the same problem, all right? You're going to see variances, different ways to explain things, yada, 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 all right? But I thought it was an interesting problem. I'm going to go to the whiteboard, and I'm going to talk through what I think I'm seeing in the problem. And let me do that, all right? Expand this out. So I'm going to write the problem down. And one thing to do, you look at the problem, I'll be honest, the first thing I tried to do was unnest the root, but it was unproductive. And I stopped and said, that's not leading anywhere. But then I looked at it, write this down for you. It's a nested root. And again, I tried to unnest it. And that's to the x power. And this is 4 plus root 15. And this is going to be plus 4 minus root 15. That's the x. And they say it's equal to the number 8. So a lot of students may look at this and say, oh, there's a trivial solution to the problem, or maybe more than one trivial solution to the problem. But I'll be honest, when I looked at it, the first thing I did is said, yeah, let me denest it. And I tried this over here. I said, maybe it denests to something like this. And it was unproductive, by the way. And what I do, I square both sides. I get this over here. And then I get a plus b plus 2 root ab. I equate coefficients, and that means a plus b would have to equal 4. And then I'm looking at this 2 root ab would have to equal to root 15. I'd probably square both sides. I get 4ab equals 15. And this part I was saying is this is really unproductive because it looks like it's going to be nasty numbers. So I'm going to erase that and talk about something else. I'm not going to denest the root. And then what I started to notice was that the radicands, I'll claim this over here, that radicand, sorry about that. Those radicands are conjugates, all right? So more importantly, not only are they conjugates, if I multiply them together, something really nice happens, by the way. And I'm going to write that down for you now. So I'm going to say something really nice happens if I just took their radicands and multiply them together. What would you get? 4 times 4 is 16. And these are conjugates. And minus 15 now, which is 1. Now, what does it tell me? It tells me that the product of these two is 1. So they're really telling me they're reciprocals. They're telling me that 4 plus root 15 is identical to 1 over 4 minus root 15. And that's remarkable, by the way. That's remarkable. So what I want to do is, kind of look at that and go back to the original problem. Let me erase this now here. I don't need this anymore. And I want to look at that, and I'm going to kind of write that down now. All right? And what I'm going to do, I'm going to raise, oops, sorry about that, to the x power. And I'm going to raise this to the x power. All right? Now, I'm not sure what the x is, by the way, but I can do that certainly. All right? So then the question becomes is, before I do that, I want to do the roots, because it doesn't really look like that, does it? Sorry about that. I'm going to take the root. Whoops, sorry about that again. Got to be careful with the pen, right? And I'll do the square root of this side too, all right? By the way, they're both positive numbers. 4 plus root 15 is certainly a positive number, and 4 minus root 15 is certainly a positive number. So let's be a little more careful about this. So 4 plus root 15, that's the root of it, by the way, equals, well, the square root of 1 is just 1, and I get this over here. All right, hope I didn't go too fast with that. All right, I'm looking at this, and I'm going to raise both sides to the x power now. All right. Okay, let's write this down now and see if I can do it. I'm going to go back to the original equation now. But again, this is a nice fact to know at this point. And the original equation is going to be 4 plus root 15, the root of that, raised to the x power, plus, and again, I'm just copying what the original problem is now. And that equals 8. And what I'm going to do is just substitute now. So for example, this thing here is identical to this thing over here. And I'm going to put that down now. And what are you going to get? You're going to get this. You're going to get 1 root 4 minus root 15 to the x power plus root 4 minus root 15 to the x power is equal to 8. Again, it still looks nasty to me, so I can make a substitution now. And the substitution I want to make is u equals the root of 4 minus root 15. By the way, this is something I got to keep in the back of my mind because I really don't want u. I'm just looking for an easy way to write this over here. So it's going to be 1 over u to the x power plus u to the x power is equal to 8. Now what I'm going to do is I want to get rid of the fraction, and I'm going to multiply both sides by u to the x power. And you would get 1 plus u to the 2x equals 8u to the x. This is starting the quadratic or more familiar in form to me. Let me write this over here. So u to the 2x minus 8u to the x plus 1 is equal to 0. And then I would probably go to the quadratic formula, all right? The problem with this over here is it's quadratic in form, and I'll tell you what it is. It's really u to the x squared minus, I'm sorry, I made a mistake in the writing department. Let me get my eraser out. U to the x plus 1 equals 0. So quadratic formula, u to the x, kind of crazy looking, isn't it? Equals, gotta be careful here, twice the coefficient of the square term, which would just be 2. The opposite of the coefficient on a linear term, which would be 8, plus or minus. All right, I got to be careful. This is radicand stuff. That coefficient on a linear term, which is minus 8 squared, which is 64, minus 4 times the coefficient on a square term, which is 1. So that's 4 times the constant term, which is 1. So just 4. All right. So I'm getting a little bit warmer. U to the x. This is going to be 8 plus or minus root 60 over 2. 8 plus or minus, well, there's a 4 and a 60. 4 times 15. The square root of 4 is 2. So 2 root 15 over 2. So u to the x is equal to 4 plus or minus root 15. All right? Boy, that's a familiar number, isn't it? That's crazy looking, isn't it? So now the question is, what do you do about that? Well, I think I know what u is, but I got to remind myself. It's so familiar, isn't it? Oh, use this thing over here, which is going to be the root of 4 minus root 15. I'll write that down. So it's 4 minus the root of 15 to the x equals 4 plus or minus the root of 15. I'm going to write two equations down now because I do see two things. I see 4 minus root 15 to the x power is equal to, let's be careful here, 4 minus, oh, you know what? Yeah, I think I did okay. I'm sorry, I made a mistake already. I got to go backwards. Get my bigger eraser out. And I can't blame it on memory, but because as I'm writing, I'm starting to realize I wrote something down incorrect. I said what u was, it's up there, but I wrote the wrong u down. I'm sorry about that. Let me do that again. So the u is actually the root of 4 minus the root 15. That's what the u is, and I'll raise that to the x power. And this equals 4 plus or minus the root of 15. All right? Okay, I got troubles, and my troubles are I got two different things to look at now. And I'll write down what those two things are. The two things are going to be the root. You know, I can write that a little differently now. And I'm going to write it as, because the root is actually just a half power, right? So let me get my eraser out again. it's going to be 4 minus root 15. And it's going to be half power, so it's x over 2 now. And that equals 4 plus or minus root 15. And let me write this down. So it's going to be 4 minus the root of 15, x over 2, equals 4 plus root 15, or 4 minus root 15, x over 2, would equal 4 minus root 15. All right, there's two of them. I'm going to say this one looks trivial to me. And I'll tell you why it looks trivial to me. Looking at it, they should be equal, so that means this power has to be 1. What would make it 1? X equals 2. Boy, that's a really simple answer, by the way. This one looks a little more complicated to me. All right, so I'll write this one down for you. And I'm going to use logs to do it. And what do you get? You're going to get x over 2 times the natural log of 4 minus root 15 equals the natural log, using logs by the way, plus root 15. And I'm going to say x equals, it doesn't look that bad now, it looks like 2 times the natural log of 4 plus root 15 all over the natural log of 4 minus root 15. All right, by the way, it's a good answer, by the way. I mean, you could box that and say I'm done over there. But I got suspicions about this because the numbers keep popping up, like 4 minus root 15. So I want to go back to the beginning. I know it's a long time ago. And I think we showed that these are actually reciprocals of one another. All right, they're actually reciprocals. I know I erased that, but we showed they're reciprocals. All right, so what I want to do is go back over here and say this one's equivalent to, maybe it's going to simplify, who knows, 2 times the natural log of 4 plus root 15. And I can write the bottom down. It's actually the natural log of 1 over 4 plus root 15. All right, they're reciprocals. All right, let's keep going. X equals 2 natural log 4 plus root 15. I'm going to use rules of logs on the bottom. You get natural log of 1 minus the natural log of 4 plus root 15. What does that give me? X equals, you get 2 natural log 4 plus root 15. Now the natural log of 1 is 0, so what am I left off with? Minus the natural log of 4 plus root 15. What happens now? These cancel off, and we're left with minus 2. So we have two answers, by the way. X equals 2, x equals minus 2. There's two answers to the question. Now granted, if you want, you can go back and check them, and they're not bad to check, by the way. You could check this one, and they're both correct, right? They both work out beautifully. Thank you.